Pavel Simikov. I work on Google Cloud Platform. My focus is DevOps and CI/CD products, Cloud Build, Cloud Deploy, Artifact Registry, and I'm also supporting secure software supply chains. So in this tech talk, we're going to talk about deployments for VMs, right? Today is November 15th, 2022, and of course we're very excited to work with Kubernetes, which is a very capable platform. But I don't want to forget about VMs, right? VMs been there for many years, and they're very capable, and they can do pretty much everything that Kubernetes can do. It's slightly different way of working, but they are no less powerful. And Kubernetes itself runs on VMs. Now, I'm often asked, what Google Cloud CI/CD tool should we use to deploy to Compute Engine? Or, for example, what is the right or best tool and from which vendor, right? So the answer here is that there are many options out there. Today, I'll show you how to deploy virtual machines on Compute Engine using only Google Cloud Build and Terraform. Now, just with those two products, we can achieve zero downtime, blue-green deployment, right? Now, in orange in the center, you see my GitHub project where you find all the code, this video, and the code samples, and the slides that I'm using. You can repeat everything you see in this demo by yourself, following the do-it-yourself. Now, so what is blue-green deployment? So at a very high level, it seems very simple. Let's look at users on the left. Users access some kind of load balancer that is able to point to two different VM pools. So currently at point 2, a load balancer points at green pool of VMs, but it could be made to point to a blue pool instantaneously, so to speak. Now, at the same time, we have quality assurance engineers and developers. They need access to both pools, right? Because they may want to test blue while green is being served, and so on. Now, because pools have a variable number of VMs that are typically auto-scaled, you need load balancer to enter green or blue pools on all sides for users and for QA and developers, right? So this is basically the simplest blue-green deployment. You have 3 load balancers, the splitter, green load balancer and blue load balancer, and then you have 2 pools. One pool with green VMs, let's say version 1, and another pool with blue VMs, version 2, right? So conceptually, this is very, very simple. Let's double click on what it actually is in reality. I'm linking an article to this talk that describes how to build managed instance group just one, not 3, but one, and route external IP address into the VMs into this managed instance group. So if you look, and that article has this diagram, so you can read. That's another 20-page read. So basically, your VMs are in here. They are organized in what's called managed instance group, so that the manager can then auto-scale and upgrade and do many things with those VMs. And then the group is in a zone, and zone is in a subnet. There's also another subnet for the load balancer. And then you have few auxiliary things. You need URL mapping, you need forwarding rules, you potentially need a SSL certificate if you have SSL, you need health check, and so on and so forth. So if you to set up managed instance group by hand, you need all these objects, resources to be created in Google Cloud. Now, if you were to use gcloud or APIs to do that, it would be very tedious. And if anything fails, you have to figure out how to repair. Let's say if this, you try to connect these two and it didn't work, or if you need to replace the VM, you have to figure out how to detach and reattach. So doing construction of such a complex scenario with gcloud or API is not practical. And of course, that's what gave rise to Terraform. Now, Terraform. So, just run Terraform when it comes to life. That seems simple, but let's just figure out how to run Terraform in the cloud. To do that, we have to actually consider how we're going to deploy the code and changes to Terraform and how Terraform is going to run. Now, on this diagram, I'm capturing entire developer operations flow that will happen in this project. So imagine that you will start with empty project, which is gray, and then you will use code in this demo to provision and set everything up for you. So my code will do that. So let's talk what actually one needs to run Terraform. So now let's start kind of in reverse. To run Terraform and have variables, right, that, for example, control whether you point load balancer to blue or to green pool, right? To run the Terraform, somebody needs to start the Terraform process. So who would that be in the cloud? Well, cloud build is something that can actuate the Terraform. So there will be cloud build pipeline, and in case of Terraform, they typically have apply and destroy, right? Apply that takes the plan and makes changes forward to achieve that plan, and destroy that destroys everything, when you no longer need resources. But cloud build will execute the Terraform plans by triggering Terraform. Now, and how would cloud build know when it's time to do the job? Well, through cloud build triggers, they need to be connected to some kind of source code repository that contains all the plans, and and when changes are made to the repositories, that's when the trigger will actuate appropriate pipeline and to execute the Terraform. Now, so who would actuate the changes? Well, that's the developer. So you, after you have this that all of this set up, you would make a commit, changing, let's say, TF variables to point from blue to green, right? That's the blue-green cutover. So you'll make a change. You are the developer here. You'll make a change to your source code repo that will trigger the trigger, and that will call the pipeline, or will call the Terraform, which will then construct all the objects. So very good. So the blue set of arrows is what will happen on every deploy, right? That's the kind of GitOps deploy process. Now, but how all of this is going to come to life? Who's going to create source code repo? Where the trigger is going to come from? So somebody needs to bootstrap that, and that's where we have basically for every project you have some kind of bootstrapping that has to happen. And I have this outlined in red, right? So let's see. In my demo that I have in the source code that I'll show you, I actually have another cloud build that will create the source code repo and the triggers. It will populate the source code trigger in your project with the GitHub source repo. It will just clone it and make a copy of it. Because my GitHub repo has all the components that you need, all the pipelines, all the code that you need to manage the project. So Cloud Build will create the repo, populate the repo, create the triggers. Now, who will run this Cloud Build? Well, you will. So you will come to your laptop and you will execute the shell script that is also comes from my repository. And that shell script will start the build, which will clone my repo, create new source repo in your project, put the clone here, create triggers, and from that point you will be able to execute the blue, the GitOps, and the red is the bootstrapping. Now, so here I have often the question, why not do everything in Terraform? Well, it's not possible to do everything in Terraform. So for example, you need to enable basic services and give permissions to Cloud Build, and you couldn't do that in Terraform because Terraform requires, let's say, bucket to be created where the Terraform going to store its state, right? So there's still a little bit of something that needs to happen that before Terraform can be invoked. And we're trying to minimize that, of course, but there is something that always needs to happen before Terraform. All right, so now let me walk you through the actual demo. So if you read the DUI section to this video in this project, so intent is that I'm going to show you how blue-green deployment works, but you also can repeat and set it up in your project. So here I'm gonna start assuming that there's an empty project, and we're gonna get you right in the hypothetical project to get to blue-green deployment. So you will come to shell and following the instructions, and you will just execute the shell script from my repo. So when you execute this, the screen will come up. So it will say, well, you have to pass the project which you want bootstrapped, right? So it will first figure out whether you have gcloud installed, and that's the only dependency. You don't need Git or anything else, only gcloud. And then it will basically warn you that it's going to modify the project, enable APIs, create 4 VMs, 3 load balancers, and so on. So it's going to give you a warning. And you should also actually read the source of the script to make sure that you understand what it does to your environment. And after you're comfortable running it, you'll agree and you say yes. And after that, script will continue. And at the end of the script, right, there's no other manual operations you have to do. At the end of the script, so all of the red lines, right, all the bootstrapping will be finished. And now, if you go to Google Cloud Console and you look at the build history, you will see one build there. It's unnamed because it's kind of constructed on the fly. And you will see that there were a few steps. So we first created new cloud source repo in your project, and we copied source code from my demo project into yours, and we added few pipeline triggers. Right, so and then if you navigate, and you can see the logs. So if you've never seen cloud build, so this is what an instance of a build run looks like. You can see the steps here and the status, how long it took, and then here you see the log, and you can see online, for example, on line 46, right, we're recreating destroy trigger, and on line 51 we're recreating apply trigger, right? So all of the actions that we did are available in the log here. All right, so let's see the resources that were created by this build. So first of all, it created brand new cloud source repository in your project. It is called copy of mine, and it has everything that I had in mind. And there's only one commit, right? Commit made by cloud build, who created this repo and made the clone. So the second thing that you'll find here is that is a set of cloud build triggers. So you'll see two triggers, apply and destroy, and you can see triggers on the, so you see build history over here and here on the left nav, and here are the triggers. So apply trigger, they both attach to the same repository. They listen to your copy of to cloud source repository in your project. But apply trigger is attached to specific branch and specific file in the branch. So whenever anybody puts the change into the main branch, into specific file Terraform variables, that's when apply will trigger. But destroy is manual, right? So we don't want it to accidentally trigger, but you can trigger it by clicking run manually here. I'm looking through my notes. All right, so now, so we have the cloud source repo and we have the triggers. Now, to actually deployment, we have to make a change. So you would clone your repo, and I have the steps here: g cloud source repos clone, and you clone your repo, and you will open TF-vars in the editor. And I think I have it set to blue by default. We don't have any deployments yet, but to trigger the deployment, we need to make a change. So we'll change blue for green, right? So we basically gonna point. Now I have two other things here. You can change the version of blue and version of green deployment, right? So you basically, let's say if you have blue active, then you could put green into the new version and then test it and then promote green to a new version and then upgrade the blue version. So there are many scenarios you can have here of how you want to upgrade and which environment is active at what time. And also you could actually have canary when you have 90% blue and 10% green. It's very easy to do, but for the purpose of this talk, we're just flipping 100% of blue into 100% of green. So you'll make a change by editing the file, and then you will commit and push the change to the repo. Now, as soon as you do that, the trigger that listens to the change to this file will fire, and this is what this cloud build looks like. It will basically execute Terraform apply. Now, if you know how Terraform apply works, it will read the plan, and we will look at the source code of the plan. It will read the plan and it will say, well, I haven't created anything yet, never run before, so I have 27 objects to add, right? To set up blue MIG, blue-green MIG Katova, we have to have 27 resources to be created by Terraform. And then it's gonna run and create the resources. And a second step I have is describe deployment, because after everything has been created, how would you know how to actually see your application running? So there's a build step that actually prints out the IP addresses of where you need to go to see everything working. Now, and if you go to those IP addresses, you will see, if you go to the one against blue, you'll see this blue app and in the web page. And if you go to the green address, you will see the green app. Also, if you refresh the page a couple times, you will see name of the host changing because there are two different VMs behind in the pool for each of the apps. Now, so because apps are running, all of the objects that I showed you in the complex managed instance group diagram, all of these objects are now present in Google Cloud Console. So if you, for example, navigate to to Compute Engine instance group section, you will see two instance groups, blue and green. They have 0 instances yet because they haven't started VMs just yet. If you go to the instances, virtual machine instances subsection, you will see all the instances, and we have 1, 2 in blue and 1, 2 in green. And you can see the private and public IP addresses, but these public IP addresses are not accessible. Only load balancers are exposed. Also, if you go to look at external IP addresses, so here are the 3 IP addresses: the blue IP address of blue load balancer, green load balancer, and the one that is able to flip, I call a splitter. And here are their IP addresses. Well, and eventually, when you're done playing, you can do more changes, and you can flip, blue to green, green to blue, change application versions to see how everything working, how fast that is. It's pretty fast, because when you're gonna run apply second time, most objects are already created, so it only needs to reconfigure the load balance in the middle. So only one object needs to be changed in place. So second runs are much faster. And when you're done, you could actually execute, you can trigger the destroy cloud build manually, and you will see here it will destroy everything, and the same 27 objects that were initially created are now destroyed, right? Now, the beauty of cloud build being managed and um, service that supports very high level of SALSA compliance um, is that the audit trail remains. So even that we deleted the triggers and source code repository, the history of what was executed in this environment remains for audit purposes. And if you have audit need, you can come here and see who ran what and when. Now, and finally, because we had some bootstrap done without Terraform, right? So there is a little bit of cleanup to do without Terraform. So like we started by set up a SH script. There is also tear down a SH that will destroy the source code repo and the triggers and bring your environment back completely to the state where it was before we started, right? Now, so let me again walk through what just happened, right? We set to do blue-green deployments using virtual machine managed instance groups. We use Terraform to create 2 pools of VMs and 3 load balancers. One load balancer you can point to either group, and other load balancers are pinned to a specific colored group. And we were able to take your project, and using scripts and code in my project, we were able to bootstrap your project from ground up. We set up GitOps blue arrows there, so you could actuate deployment from by clicking the trigger in the UI or by committing a change, right? All of this got set up for you, and you didn't have to do any manual work. Now, so let's look at the source code a little bit. Let me do a source code walkthrough and speak through a few interesting things that I think one got to know. All right, so let me navigate to my project on GitHub, which is the GCP Make Simple. Here's the code base. Now let's start with setup sh. So this is a green header. Here I'm gonna check if gcloud is installed. Then I'm gonna find out your default. If you didn't pass project on command line, I'm gonna read it from what's set default in your environment. If project is not set, I'm gonna fail, and I'm gonna put the warning screen up. I'm gonna say you're about to change this project, and these things we're gonna do, and I'm gonna wait for your consent, and then you're gonna give me consent so I can proceed, right? So the first materially interesting thing, line 75, is first thing I'm gonna do is enable APIs required for this demo. So let's see, I'm gonna enable cloud build because that's what we're using to drive everything. I'm gonna enable Cloud Resource Manager. I'm not 100% sure why I need this, but I think Terraform needs that API to infer the state of the cloud, current state of the cloud before it applies changes. We need compute because that's where the VMs are for managed instance groups. And we need source repo enabled because we will create source code repository. Next, so now because I'm letting cloud build provision everything for you, we have to give it role of editor of your project. Now, you may feel uncomfortable with it, and you can decide how you want to partition or sandbox or which or who do you think has rights to do bootstrapping? Um, and we can control the rights, but the point is to automatically provision a project, somebody must have a role of editor, right? Otherwise, you cannot automatically provision the project. And so Cloud Build in your project will have a role of editor to your project. And also, it needs rights to be admin to the source repo so it can create new repo. Now, you could, after the red arrows, right, the bootstrap section runs, you could lower the rights a little bit. For example, you don't need source admin. You only need source read, right? But the point is, in any bootstrap, you need to have some kind of permission delegation to some service account that will then act on your behalf in the cloud. Right, so next thing, right? I mentioned to you that there is this bootstrap cloud build. Where does it come from? We're actually generating it in line here. Now, I wanted to generate it in line instead of pulling from uh, GitHub, because to pull from GitHub, you would need to have Git installed. So by generating it in line, I avoid any other dependencies and use of local file system. Now, so in that cloud build, right, we saw steps. So the first step was create new cloud source repo. So here's gcloud commands. I'm deleting old one, creating new one. And then I was copying my project into yours, right? So I'm creating temporary folders, and then I'm checking out new repo, and then I'm cloning, my repo, and I'm copying one into the other and submitting it. So here's the cloud builder's username. So when you look at that first commit, cloud build did the submission. That's where that happens. And then I'm adding, let me just make font a little bit larger, maybe even more larger. I'm adding the triggers, right? So I'm destroying, deleting trigger destroy and recreating it. And I'm deleting trigger apply and recreating it. And you can see the difference, right? Because destroy trigger was manual, it would be triggers create manual, but apply trigger was bound to branch and file. That would be triggers create cloud source repositories trigger, and so here's the branch and here's the file that it will look out for. And finally, right, and so now that I generated the cloud build file, I will now wait a little bit to make sure that API enablement actually propagated everywhere, because so I'm gonna try to use cloud builds and compute to make sure that all those APIs are in fact enabled, because sometimes there's short delay. After I made sure APIs are enabled, I'm gonna submit this cloud build job here for execution. Here it is. I'm actually suppressing output, so I can only focus on echo statements that I print. I don't want to see bulk output. I would go to Google Cloud Console to see that. I'm also removing the file I created, so file system is clean when I exit. And then I'm also printing help messages to give you links, right, or where to find the triggers, the build history, and the new repository, right? So this is the setup SH. Now let's look at the cloud build pipelines. So let's look at apply. Now, so this is entire content of the apply cloud build file. It has two tasks, right? Run the Terraform, tf apply, and the other one is describe deployment, where we print out IP addresses of load balancers. Now, I like to have my the body of steps to have very almost nothing in it. I prefer to source shell utilities and then call functions in them. So in that case, all of the functions are in one place. They call bash utils, and then we could just go and look. So here I'm calling tf install, and here I call describe deployment, but all those functions are in one place, and that's where we're going to go next. Similarly, if we look at destroy cloud build pipeline, it is exactly the same. It will source the same file and execute install Terraform and Terraform destroy, right? So the reason I like that setup, because it lets me to execute the same commands from my local shell as the cloud build would. So when I'm developing, I don't have to submit builds. I can execute everything locally, and when I'm confident, then I can start executing it in the cloud. So let's quickly look at what's inside, how I'm organizing my utils. Now, so one of the tasks I have here is to install the Terraform. So this is where power of cloud build really shines. So cloud build step, you have a full, virtual machine, essentially Docker image that you can configure the way you want. So I'm starting with Ubuntu, and then I'm able to do apt update install. I will install unzip and wget, which I would need. Then I'm going to do wget Terraform directly from HashiCorp. If I had egress restricted, I would have staged that in my bucket, but I don't. This is the only dependency that is used in this project. There are no other dependencies. So I'm fetching the distribution from HashiCorp, unzipping, put in the folder, and then I'm just testing it got installed. And then I'm creating a bucket. So Terraform is a stateful thing. So as it executes the plan, it does checkpointing and records where it's gotten thus far, and it records that in the bucket. So we need the bucket, which I'm creating here. So Terraform plan requires the section, provider section, and that's where the bucket needs to be specified. So I have to generate that here in line, because this could not be passed as a variable. It's hard coded, so I have to construct kind of provider Terraform to point to the bucket. But this is what I'm doing. I'm installing Terraform on the fly inside the cloud build. We could have added a step which could create Docker image and then reuse that image. That's also possible. It'd be lazy Docker image creation, right? It would be a step that says, let me check if there's Docker image for Terraform. If there isn't, let me create one. If there is, then I can exit safely. And then the next step would use the name of that image to pull from your artifact registry with Terraform already installed. Now, so let me look at apply first. So apply, so we'll call Terraform init first, because init will load all the modules and provider custom libraries. So you always call init first, and then you would call Terraform apply. We will do auto approval because Terraform supports consent. I don't need that, so it will not ask for consent. And here's I'm passing the variables to Terraform. That's the variables are in this file. Destroy is very similar. I'm doing it, and then we're going to destroy the Terraform. And what else I have? Right, describe deployment. So describe deployment just basically prints set of IP addresses. And here I'm basically, you see here, I'm just doing variable expansion inside my shell where I call gcloud to fetch IP address with specific name, because I know the names of the addresses. They have kind of fixed names. I'm resolving them, so when it prints, you see the IP address. All right, so we looked at the setup SH, that starts everything. Then we looked at pipelines, and now let's look at Terraform. So Terraform is an infra folder. So here are the variables. Here's the main body of Terraform, and here are two modules. So Terraform is very interesting. You can think of it as kind of templating language. I don't know how to explain it, but so because we need to create blue and green manage instance groups with surrounding objects, they effectively identical except for kind of color. So I am factoring that into a folder called mig, and then I can instantiate that, it's called module. I can instantiate that module twice with different parameters, and then I need one splitter. So everything related to that load balancer that is able to flip, there's only one of it, and it's somewhat different in configuration from load balancer inside that is bound to mig. So I have two modules here. Now let's look at let's look at variables first. So as you saw when we edited the file, there are three variables. What application version to deploy into blue pool, version to deploy into green pool, and what is the active color, blue or green, right? So changes to this file actuate the deployment. Now, so let's look at the main Terraform. So project comes as a variable. We set up provider. I use something called namespace. So all objects that Terraform creates are prefixed with all their names prefixed with namespace. So I can deploy multiple copies of the same project the same application into the same project. Nothing will collide because they're all namespaced. So here namespace is fixed, and S1 is the namespace. And so here's the binding for the three variables I just showed you in the TFRs file. A version of the blue, version of the green pool, and then what's the active color. And so here's the instantiation of splitter module. I'm passing project to it. I'm passing what is the active color, because splitter needs to know what's the active color. And I'm passing both instance group objects So it could point to either blue or green. So that's what splitter needs. And then I have two identical sections for blue and green manage instance group. So I am passing its color and network and subnetwork, which are defined actually in the splitter module, because all of the load balancers are part of the same VPC, so to speak. But you see how I can create two instances of module MIG here. So I'm using the same module, but because variables coming in are different, you have two different instances, blue and green. And here I'm using the splitter folder, right? Now, so let's look at the splitter first, probably. You will see very typical Terraform. So here the variables coming in, they are defined, and I create all local names which I prefix with namespace, so everything is unique. I'm creating all the networking. So there's a lot of objects to create that surround kind of load balancer. And let me just scroll to the place where we do the green versus blue. So basically, Google Compute Region backend service. So this load balancer is backed by this backend service. And there are two backends to which it can route. So one backend is blue and one is green. And capacity scaler, it says how much to route. And I'm doing basically 100% routing. I'm checking if the active color is blue, then 1 meaning 100% of capacity should go to blue group. And if active color is green, that 100% will go to green group. So this is the place where you could do canary, for example. You could say 90-10 and so on. If this is what you want to do, you would do it right here. And otherwise, there's nothing else interesting here except that a lot of Terraform takes input, not much, not many examples have output. But here I need to actually output network and subnetwork, so I can then pass it into the manage instance group. So they could be part of the same network. And now, so we looked at splitter, and let's look at MIG. There are a few interesting things in there. So again, I'm passing variables in, and there's a bunch of objects are being created. I'm also using local variables that are prefix, and I have an error in my indent here. I'll fix that. Now, so compute instance template, right? So template is the kind of meta VM, right? In order to create a VM, you have to have template from which you start. And interestingly, if you have, if you wanted to replace a version of the pool, right? So if you have a pool that runs with version 1, and if you want to transition to version 2, you need to replace template. And if you try to literally use Terraform to replace it, will fail, because it will tell you that the instance template is being in use, and that is now there's no in place change for template. You have to destroy and then create new, but you cannot destroy because it's being used by manage instance group to create VMs, so it is kind of attached to it. And if you were to destroy it, create new one, and then reattach, you would have an outage, right? Because at the period of time when you have a manage instance group that is not backed by a template. So this is where we have, you have to kind of know Terraform very well. So Terraform allows you to choose lifecycle strategy called create before destroy. What this means is that while v1 template is attached to instance group and is serving, you would create new template called v2, and you would then reattach the new one, and then you would detach the old one, and then you would destroy the old one. Versus the default behavior is you would first destroy, and then you would create, and then you would reattach. So for this specific scenario, we need to actually change lifecycle, and we need to do the same thing for the instance group manager. So it also has create before destroy. And otherwise, it just follows the article that I linked that teaches you how to use manage instance groups. Most of this code is from that article. Now let me go back to the presentation, and so let's just summarize where we've been, right? So I started by saying that, of course, GKE is top of mind today, but then I said that VMs are still workhorse, right, of cloud today, and even Kubernetes run on VMs, and you don't necessarily need new products to deploy to VMs, right? Products like Cloud Build and Terraform actually allow you to create very complex deployment. As I showed you, zero downtime blue-green deployment using managed instance groups. Now, so then what I showed you how only using two products, Cloud Build and Terraform, I'm able to bootstrap your empty new project and then set up GitOps pipeline when Cloud Build listens for changes in cloud source and actuates Terraform deployments. Right, so we basically have automatic bootstrapping, and then we have GitOps through GitOps pipeline, and then of course Terraform works, and you're actually able to see your application deployed into pools and switch between them. So thank you for your time. Thank you for listening. I hope you use cloud well, and if you need me to answer any questions, drop me a line, and I'll help you out. Please read our docs, and all the best. I see you around.